Hi everyone. Last week we stopped here, right? Page 201. Any question about photon? So, so this is the formula lah. So last week we actually learned 6 formula. So actually number 1 and number 5 is the same thing. So this is what Planck and Einstein, actually it's Einstein. Planck, he came out the idea, quantum. So he say energy is in packet. Energy is in packet, not continuous, but packet. So he then come to Einstein, he have the idea of photon. So photon is not electron or proton or what. It's energy in packet. So it comes out the formula E equals to HF. So H is Planck constant. If you're not sure what, actually you can find in number 11, the last, Planck constant. And then we can use number 2, F equals to where, so number 1, number 2, where F equals to C over lambda. So actually this one come to from 4 formula, V equals to F lambda, but because electromagnetic light wave has light speed as speed, so we can see this, so F equals to C over lambda. So we substitute in, we will get number 6. Number 5. Okay, I don't know why they are so far away. So actually it's number 5, E equals to, substitute F equals to C over lambda, so HC over lambda. Actually, 1 and 5 are the same. They just substitute in number 2, then they will get number 6. Hi, Joshua. Okay, then now come to number 3 and number 4. Okay, and number 6, 3, 4, 6. Okay, 3, 4. So this is 1, 2, 6. Sorry, 1, 2, 5. Okay, now number 3 and number 4, what we get? We get lambda equals to h over p. So lambda equals to h over p. So lambda equals to h over mv. So actually, what is the p here? P here means momentum. So yes, it's our form 4 momentum. Here, form 4. See, form 4, number 5. Under force and motion 1, number 5. Momentum equals to mv. Why we say that? Because we say that it's under, what is it? Forgot the name already. The person who say wave particle dualities. De Broglie. So De Broglie say everything. If it is light, it could have wave, it could be wave, or it could be particles. It has the duality. But when it's wave, when it's particles, when you observe it, then only you know it's wave or particles. Right? So for example, electron. Without electron is a particles. But actually electron also got wave characteristic. So he said everything could have wave particles duality. I mean particles Okay, not human lah, human too big lah. Okay, so it's in the micro world. We are in macro world, right? So that's why you can have wave, lambda, wavelength, and you also can say it has mass. Particles has mass, but wave don't have mass. So under de Broglie say de Broglie. But when I memorize their name, I use bahasa lah. I break that in suku kata de Broglie. So actually it's de Broglie. Okay, then come to number 6. So just now here. 1, 2, 3, 4, 5. Number 6 is P equals to NHF. Be careful. Now they recycle. This P is momentum. Number 6, the P equals to NHF. This P refers to power. Okay. Hi, Aiden. Don't worry. Come in, then join. Okay, so now the same thing. F also can substitute formula number 2. Okay, F equals to C over lambda. So we can say P equals to NHC over lambda. Okay, if they ask for power. Okay, so if they ask for momentum, use this 3 form. If they ask for power, use P equals to NHF or NHC over lambda. If they ask photon, it will be 1 to 5. Okay, so big P, right? Actually, in textbook, it's big capital P. But in formula, they put small p. Yeah, this is the real SPM formula. Okay. So actually here, be careful lah. Be careful lah. This P and this P are different lah. This P stands for momentum, de Broglie. Then this P stands for power. Understand? Okay, so now 1 to 6 we have done. Actually, this quantum chapter quite easy because they just touch the surface on it, let you know the concept on it. So actually not hard for calculation because they would tell you what should you find properly, very clear. So you look at them, substitute correct formula, done. Okay. Now see, a beam of light or power. Wow, if they say power, use this lah. What is the number of photon means M? Okay, release per second N. But here got a tricky part. Means the tricky part is the prefix. Prefix is the P. P is pico. So I told you, right, how to find prefix. If you don't remember, it doesn't matter as long as you got calculator. Then I got nah. What is this? Actually, this is 1.00 milliwatts. And this one is what? This one is lambda equals to 560 nanometer. If possible, you memorize lah. If not, cannot. Okay, you got 2 ways. Anyone still don't know how to use prefix? How to press prefix in your calculator? It's okay, just let me know. I just want to assure. Anyone raise your hand or you can show in the chat. Okay lah. You still got lah. Okay lah. Never mind. I teach one more time. 哎，你们真是的，一群小可爱。 Okay, okay, if you have this kind of calculator, FX570MS. Okay, it's over here only. Can you see it's yellow? Yellow means you just press shift, yellow, shift 7, it's mega. So 7 is M, capital M, mega. Then what is small m? Small m is milli. Okay, so if you press 1 mega, you press 1, you press shift, you press 7, you will see 1 mega. Okay, so 1 milli, you must press 1 first. If you just directly press milli, you got nothing. So 1 milli, you will get 1 milli, and you press equal again, you will get 1 times 10 powers of negative 3. Okay, so it's mega, giga, tera, micro, milli, kilo, nano. Right? Well, this one quite easy to check lah. This is the old version of MS570 MS, the same thing lah, mega, giga, tera, micro, milli, kilo, same thing lah, nano. Okay, then ES, if you have this kind of calculator, I advise you to change to this one. I don't know how to get good things, but this is the latest, and this is the best. This one can get many things. Okay, how do you get the prefix? For example, just now, how much? 560 nanometer. Okay, so you just press 560. Nano, you just press option, then you press number 3. Number 3 is engineer symbol. Then you press, I forgot nano is how much. I got my calculator. So it's 560 option, engineer symbol. Nano is number 3. Okay, nano is, okay, you will get this. Milli, micro, nano, number 4, pico, number 5, pico. Okay, so you get this. Then number 3, then you will get 550 and you press equal sign. Now you will get this. Okay, if you want to change to decimal, I believe all of you know how to press this. Yeah, okay, so you get 5.6 times 10 powers of negative 7. So nano is 5.6 times 10 powers of negative 7. If you can memorize it, also good. 560 times 10 powers of negative 9. So the calculator will help you change into standard formula. Okay, up to you lah. Okay, like big P, right, teacher? Big P. Okay, the power. Okay, correct. Thank you, Jared. Yeah, number 3. Yeah, number 3. Now get it, huh? Okay, so same thing. If this one can see directly on here, just press shift. But this one, the latest calculator, very good. So option, number 3, engineer symbol, then you choose it. Okay. So they call prefix. It's called prefix. Means what? It's not only what, but milli what. Not meter, nanometer. Meter in pico. Right? So you must be alert to the prefix. Alright, so now let's Let's start to the, it's Josephine. Yeah. Oh, Jared, Josephine. Oh, okay. Hi, Josephine. Nice to meet you. Hi. Okay, so now look at this 7.2 photoelectric effect. I estimate 9:15 can finish lah. If can finish earlier, we over earlier. Okay, so actually, what is the meaning of photoelectric effect? We skip all of this first. Oh, yeah, maybe we look at this first. What's the difference between photoelectric effect and Einstein photoelectric effect? Actually, I feel they are the same, like photoelectric effect. So I use this diagram to explain first, then I show you the video. Okay, so I show you the diagram first. So this is a copper. This is a copper. Okay, this is a copper atomic model. Okay, so you can see that copper actually sometimes got say 1 plus, 2 plus, 3 plus. Means the outer layer of copper very easy to be released out lah. So anyone can tell me why this electron will escape out? Anyone can tell me from your chemistry knowledge why sometimes the valence electron will escape out? Anyone try? Ionization to make it chemically stable. Very good, very good. Achieve stable electron arrangement. Thank you, thank you, thank you. Yeah, I didn't Jin Yang Taishon. If you don't mind, I tell your name. Sorry. But very good. Thank you. I like interaction. Yeah, why ionization happen? Because very easy. This electron get enough energy. This energy, so it got enough energy to escape. So this energy comes from what kind of energy? First, maybe heat. You heat it up, it will release. You heat it up until they can break the bond. So it will go out with kinetic or kinetic energy. So when it has enough energy to ionize means they break the bond. Okay, what is bonding? Bond actually means attraction force. Attraction force between molecule or between electron to the proton. So enough energy to break bond and escape out. Or for number 2, you give light energy. Also can make it break bond and escape out. Okay, so this is called photoelectric effect. Okay, and electric. Okay, photo means light. You shine the lights on the electron. It gains enough energy to break bond. Then it will go out with maximum kinetic energy. So now here you need to clarify what? Photoelectric effect. Effect means the effect lah, kesan daripada cahaya. When the light shines on a metal, okay, it will get it will get the light energy. This light energy in quantum, we call it as photon. Okay, when we say photon, we are talking about light energy in package. Okay, it's light energy in packet. Not continuous one, is packet. Then it will be absorbed by the electron to break bond. So the energy will use, for example, let's say here got 10 joules of light energy. Then it will use 4 joules of energy to break bond. So the energy used to break bond, we call it as work function. This energy, even though no words of energy, we can say it's work function. Okay, it's energy. Then once we use the 4 joules to break bond, we still left how much? 6 joules. So 6 joules of energy, we will use it, convert it to kinetic energy totally. So it will fly out with 6 joules of kinetic energy. Alright, so this is the theory of photoelectric effect. So now this is a metal surface. We shine the light. Electromagnetic radiation. Actually, not only the visible light. So is last week we recall one is all of the wave RMIVU X gamma, because Roy going to give birth. Okay, then remember R means really long wavelength. So here R has longest wavelength, means this side got shortest wavelength. Means V equals to F lambda, F equals to V over lambda, means F is inversely proportional to lambda. So actually, according to the formula we learned before, E equals to HF, means photon depends on the frequency. So actually, we should look at frequency. Frequency here, longest lambda, lowest frequency. So lowest lambda means highest frequency. Okay, so obviously, violet light have higher frequency than red light. So violet light or violet ray has higher photon than red ray. Okay, so we can get a conclusion here. The red ray has lowest frequency, so the photon also lowest. Violet, according to the spectrum here, has highest frequency. So to the visible light, violet will have highest photon, highest light energy in packet. Okay, so now if we shine the light onto the metal surface, then what will happen? Photoelectric effect, because electron will be escape out. Enough energy for it to break bond and release out or emit out. Electron will be able to emit out, and we will connect it to an anode. Then this is cathode. So when the electron release from this surface, we call this as cathode. And when I accept electron, because electron will be attracted to positive, we say this is anode. It's different from your chemistry. Your chemistry got different way to say anode cathode. But in physics, we only got one way. Cathode, negative. Anode, positive. How do I remember? Okay, I remember this is cactus. Okay, this is cactus. The cactus got so many needles. The needle is negative. I remember in that way. Okay, you can have your own way. Okay, but for physics, only got one. Forget about chemistry. Physics only cathode negative and not positive, right? Forget about chemistry. Chemistry, you got voltage cell and you got electrolysis. So, but physics only one. All right. So now, when electron is emitted out, it will go to the anode, and then it will go through the emitter. You will see the emitter pointer. Pointer means this needle will be deflected. Pointer is deflected. Okay, then it will go like this. So in the beginning, no current because the circuit. If the electron, if the electron is not released, you will see in between them space up. So this is not a complete circuit. But once the electron is released to the electromagnetic radiation, let's say a light, then electron will come up and complete the circuit. Then you will see emitter pointer deflected. So now you must be able to explain what is photoelectric effect. Here, when light, okay, you don't want to remember this thing, right? When light of suitable wavelength are incident, or we say are shown. What is shown actually is shine, shown is the past participles. Is are shown means the puncher. Now, barrier puncher and depuncher on metallic surface, then electrons are emitted. Okay, so photo means light with certain wavelength is shown on the metallic surface or on a metal. Okay, electron will be are emitted out. Emitted means release out. Emitted means release out. Okay. Okay, now this phenomenon called photoelectric effect. Now let's see a video. From 5 to 7. Right, look at Lonnie. Lonnie. I forgot his name. Lonnie.
We're in the demo lab with Lonnie, where he set up a photoelectric.
See, this is the photoelectric circuit. Here got light. Light means it's a photon. Photon means E equals to HF. It's energy in packet. Photon means energy in packet. Now shines inside here. Inside here got the metal surface. And here is the connection. Actually same as like just now. If no electron to connect them, they are open bracket, means no current. Then they connect it to this is emitter. Then they project it here. This is the multimeter, something like emitter. Okay, then see what happens. This is white light. So white light means from here got Roy give birth. Means inside here contains the highest photon. Okay, because violet has highest frequency, so photon is also the highest. So you can see now the current is the highest. White light.
Effect experiment. He has white light impingent on a metal, and the energy of the photoelectrons emitted are shown on the meter at right. If he puts a red filter in,
If he put a red filter, means now, before this we got Roy, K, 红橙黄绿蓝靛紫. After this filter, only got what? Only got red ray. Red ray has the lowest frequency, means photoelectron is the lowest. So photoelectron, photon. The energy, light energy will be the lowest. So when it shines inside the metal surface, not enough energy for electron to escape out, to break bond and escape out. So that's why you can see current here is 0. No electron come out. See, before he put light filter, it's maximum. After he put red,
if he puts a
no more current.
red filter in the path, now only red photons can strike the metal, and you can see they do not have sufficient energy to eject photoelectrons. If we go to higher energy photons, say go to yellow light, that's
Okay, let's recall. Okay, Roy gave birth. 红橙黄绿蓝靛紫. Okay, so Roy has lowest frequency. Means higher, lowest, according to visible light only lah, lowest photon. So now yellow have higher frequency than red. So means photon would be greater than red. See what will happen?
shorter wavelength and higher energy photons, they may be able to eject photoelectrons.
Yeah, see now? Yeah, here shows the reading, means yes, now electron can be emit out, but a little. Let's see what will happen next if he keep changing the color.
And indeed, photoelectrons are emitted, but with a relatively small energy. If we go to higher still photon energy,
So now come to the green. So higher frequency means higher than yellow. The photon is higher than yellow. See what happened?
green wavelengths, that's shorter wavelengths still, higher photon energies, we can see
Increase.
photoelectrons emitted at a higher energy. Now we can still go to higher energy photons. Blue photons.
So now comes to the blue. Blue actually has higher frequency than green and yellow. So the photon would be higher.
Photons in the blue region are the highest energy visible photons, and Lonnie has a blue filter that will pass only blue photons. Putting the blue filter in
Ta-da! 6, 7, just now 3, now 7.
the path shows photoelectrons emitted at the highest energy. So here's an example of the photoelectric effect.
Okay, so photoelectric effect means it shines a light with certain frequency on the metal. Electron is emitted. Certain frequency means not including the red. Red is frequency is lower than minimum frequency. So red cannot have photoelectron effect. Sorry, photoelectric effect. Okay, here doesn't show violet and ultraviolet, but another experiment will show. We look at the calculation first. Okay, so now you understand why we need to memorize Roy give birth and why we should memorize the frequency. Okay, so now oh yeah, like that. Energy we can say energy in joule and also can be in 1 eV. So 1 eV equals to 1.6 times 10 powers of 19 joules of energy. And then you can see here, what is it? You can see all of the wavelength. I mean, the visible light wavelength all around 100, 400, 500, 600 nanometer. Different color lah. Now we look at page 204 first. Okay, from the demonstrate just now, we can say there are 4 characteristics of photoelectric effect. And anyone, can you type up what is photoelectric effect? When light wave, can you type? Show me you remember. Try first. If you don't have output, you have to remember. Yeah, Bethany. Yeah. First half correct, but you forgot the electron. Yeah, add electron. Very good. Yeah, Dylan. Yeah, very good, Dylan. True. Yeah, very good. Yeah, Bethany. Yeah. The rest, if you don't look at your friends one, can remember. You try. Type half also can, no problem. Hi, Chen. Yes. Hi, Josephine. Can, yeah. Certain frequency also okay. Certain wavelength also okay. Yeah, right. A light with certain wavelength or frequency. So wavelength of frequency yeah, can is shown to the metal surface. Electron is emitted. Okay. Means got light, got electron come up. Okay. What is exact definition? Maybe we can get textbook. As long as you have the keywords, you can make your own sentence, no problem. The proper one. Textbook say this. So if in exam, if anything you feel okay, you can find textbook and refer. Okay, when a metal surface is illuminated by a beam of light at certain frequency or frequency better, electron can be emitted from the metal. So electron emitted lah. Okay, so you can say light with certain frequency is illuminated, is shown. Illuminated means direct lah, direct the light. Yeah, this is textbook lah. You can copy it down. So this two, if you change the sequence, you say light shine on it, metal is shine by light, also can no problem. Okay, light on metal surface, electron will be emitted out. So the energy, type of energy change is a photon. Photon means light with certain frequency. Photon means light with certain frequency. Let's say 10 joules shine on metal surface. It will use, let's say, 4 joules of energy used to break the bond, we call work function. And it will release out with 6 joules of kinetic energy. Right? So you can see that energy cannot be destroyed because before 10, after 6 plus 2, still 10. Just they change from one form to another. Okay, so now we say that first characteristic of photoelectric effect, the higher the frequency. So the higher the kinetic energy of photoelectron emitted from the metal surface. For example, if this is 20 joules, we still just use 4 joules of work function. Break bond means kinetic energy now will have 16 joules. Okay, so greater photon, greater kinetic energy. Because the work function fixed already. Work function means break the bond. Okay, now second characteristic is electrons are not emitted from the metal surface unless the frequency of the light wave is higher or is greater. I prefer you will use greater than the critical value of threshold frequency of the metal. Apa ini? Threshold frequency means minimum frequency lah, of the metal to release the electron called threshold frequency. We also use F not as symbol. Okay, normally I call this as not zero, because not, I'll call it as not. Not means nothing, means it is a whole. Remember nodal line, antinodal line. So not is a point. So I'll call it as F not. Okay. So like just now, red light. So yeah. I think you all draw here better. You draw this one here easier. So first of all, let's draw a metal surface. Metal. Then what light is the best? Purple. Not purple, we call violet. Violet. Okay, so E equals to HF. Photon. Violet light has highest frequency, so it has highest photon energy. Let's say 10 joules, let's say. So when it shines to the metal surface, this metal surface has, so need to spend 4 joules. 4 joules of energy to break bond. Actually, not break bond, but another words. That's okay. Now you tell we say 4 joules is called work function. Is W naught. Okay, W naught equals to HF naught. What is F naught? F naught means threshold frequency. What is work function? Actually, work function also means minimum energy need to be absorbed by metal to emit out the electron. So let's say HF naught is 4 joules. Okay, means now electron can be released. Electron can be released out with 6 joules of energy. What is this 6 joules of energy? Is kinetic energy. So actually here 10 joules is energy, 4 joules is energy, 6 joules is also energy, just in different form. Okay, then how to know how much energy is needed? We call it as the energy to break the bond is called work function. how to get the work function. We're still using HF, but now we use HF not. So every metal has its own threshold frequency. Different metal, different threshold frequency. Like chocolate. Why some chocolate just need 1 ringgit. Some chocolate need 10 ringgit. Some chocolate need 20 ringgit. Only you can afford them. So same thing lah. Different metal have different threshold frequency. Okay, so this is the energy change. Now, dum, dum, dum. Okay, so now, when electron is released out, that's why we have kinetic energy when it's emitted out. Kinetic energy of photoelectrons depends on the intensity of light. Does not. Okay. Okay, what is intensity of light? Anyone can tell? Actually, it's IV, which we have learned in Form 4, but we got no calculation in Form 5. Okay, now we can actually there are some calculation. So light intensity, now we just treat the light intensity as brightness. Okay, very bright means high intensity of light lah. Very dim, 很暗，有光，但是暗暗的 is dim lah. So it's low intensity of light lah. Okay, the increase in intensity of light does not increase the kinetic energy because kinetic energy depends on what? Depends on photon. Okay? Depends on the frequency of your light source. Okay, let me charge my hands, my computer. Okay, now. Okay, the photoelectron emitted from the surface is photoelectron emitted from the surface is what? Is exists. Yes, exists. Means even though low intensity of light, for example, violet light, even though not so bright, low intensity means dim light. Even though dim light, we still can see electron is emitted, 1 or 2. Okay, still got. Okay, then now remember, maximum kinetic energy of photoelectron is of the light. I think depends on the light frequency or photon. Okay, then intensity means the intensity of light means bright or dim. Okay, affects the number of electron emitted, and the frequency of light. Affects the presence of emitted electron. Okay, red light will not cause the photoelectric effect, no matter what the intensity. Means greater intensity means very bright. Red light also no photoelectron because the frequency of the red light is smaller than threshold frequency. Okay, so smaller means photon not enough lah. So maybe you can draw this out. This is a metal. So red photon means E equals to 3 joules. But what is the work function? 4 joules. So 3 minus 4 still not enough for electron to be emitted out. So we say no photoelectric effect, no electron. All right. Okay, so now a weak violet light means low intensity of violet light. Will eject only or will emit only a few electrons, but their maximum kinetic energy are greater than those for intense light of longer wavelength. Longer wavelength means lower frequency lah. So we can represent it by using this. We can make a diagram in this way. So same thing. Work function. This is a metal. Work function means minimum energy need to be absorbed to break bond is 4 joules. So if this is E equals to HF violet, means it is maybe 50 joules. Okay, so the electron that will be emitted will have kinetic energy about 46 joules left. Okay, now let's say green, Roy Gipper. So green has lower frequency than violet. E equals to HF green. Okay, so let's say this is 35. Okay, 30. Then the electron will be emitted in kinetic energy 26 joules. Okay, so work function already fixed for joules. So you have higher energy, you have higher photon, means you have higher kinetic energy. Okay, so this is what they say here. Even weak violet light means very dim, low intensity, but it still have maximum kinetic energy greater than other light. Okay, greater than other light. Okay, so then now what happened to light of high light of high frequency will cause photoelectric effect, but light of lower frequency, regardless of red light, cannot cause photoelectric effect. So if you want, you can draw one more time. So red E equals to HF red maybe equals to 3 joules only. So not enough for electron to be emitted out. Okay, so then intensity of light will cause what? So we can say metal with work function means minimum energy need to be absorbed to break bond, 4 joules. Okay, so we can draw like this. This is low intensity, one only. So high intensity is like more brighter. High intensity of light, we say is brighter. Brighter means more violet light ray at once. Okay, so E equals to HF violet. So it will have 1, 2, 3, 4. One time will have 4 electrons emitted out. But each electron will move in kinetic energy 46 joules. Okay? So now if green light, high intensity means one time got more light ray. Okay, so E equals to HF in green. So one time could have more electron, and each electron will go with kinetic energy 26 joules. And this is all I give a rough number only, not the real number, so that for you easy to understand. Okay, so now understand low intensity, high intensity means brighter, dimmer, brighter, dimmer. Okay, Xiaoqian, high intensity equals to more photoelectron, high frequency, more kinetic energy. Yeah, conclusion, very good. Right, we can make the conclusion. So high intensity of light means brighter light. High means you will get more greater number of electron molar. You will have more electron emits out at once. Okay, so now high frequency of light means higher photon. Photon means energy, means higher kinetic, maximum kinetic energy of electron. Yeah, very good conclusion. plus photon equals to E equals to H. Thank you, Xiaoqing. Okay, done. Yeah, intensity affect numbers of electron emitted out, but not affect kinetic energy. Brighter or dimmer, more or less electron, but energy depends on frequency. Yes, higher photon energy means, so like just now, higher photon energy, 50 joules, means higher kinetic energy. Lower photon means lower energy. 50, since work function is fixed for intensity and frequency. Intensity means bright or dim light. Frequency means, now you just remember in this frequency means color of light. Intensity means bright or dim. Frequency of light means color of light. Very good, you all asked. The other question? If no question, then we can start calculation. Then we can finish. Yes. So this quantum quite surface only. They want us two difficult questions. Okay, so now 205. So Einstein photoelectric theory talking about, he summarized part of the energy is blah, 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 blah. It's actually used to release an electron from the surface of metal, overcome the binding force. I think it's binding. Binding means you bind them into an atom. Yeah, binding force. Let me check textbook one more time. Not bonding. Bonding is two atoms. Thing is binding force. Einstein applies the Max Planck is area of photon is from each quantum of light is discrete packet of energy. When photon arrives, the photon will be fully absorbed by the electron. This energy is used to release electron from the metal, and the extra energy will become kinetic energy. Usually, we'll acquire to compare later. Okay, they didn't say. So work function means minimum energy required for photoelectron to be emitted from the metal surface. So the minimum frequency called threshold frequency. Okay, textbook doesn't say it's what kind break. Textbook never say break the bond or overcome the bond. I think it's binding force. Overcome. So it's minimum energy used to is absorbed and used to release electron means overcome the binding force. And the rest appears as kinetic energy maximum. Okay, write down the Okay, so now 8. What page is it? 206, like 206. Write the equation of Einstein photoelectric equation that relates to photon energy E, work function WO, maximum kinetic energy KE. So we say that actually is E equals to work function plus kinetic energy in maximum. Okay. So actually it's same like just now what we draw lah. Max photon, let's say 50 joules. Use 4 joules to overcome the binding force. 46 joules go up as kinetic energy. Okay. Then, if we want to write properly, we can write in this way lah. Actually, E equals to HF from your formula number 1. Photon energy. Photon is energy, HF. Work function is here. Number 8. They do not put a note. I advise you to put note. The W naught equals to HF naught. So apa ini? We call this is work function. Means energy absorbed by the electron to overcome the binding. Okay, so we call this is work function. This as we call it as threshold frequency. Threshold frequency. Okay, and KE max. Actually, we learned in Form 3, but they appears again in Chapter 5. Kinetic energy, E equals to half mv squared, or here later I explain that. So half mv, maximum means velocity also maximum. So now, we can rewrite it. E equals to HF equals to HF naught plus half mv max squared. And you will find out. Let's recopy this formula, number 7. HF equals to W plus half mv squared max. This is number what? Number 7. 7 is HF equals to W plus half mv squared max. W, yeah. So for me, I will feel number 7 confusing. Because it actually comes from this equation. Okay, so HF is E equals to work function plus KE max. I would rather use this as original formula. Okay, so but they are giving number 7. So HF actually is photon energy. W is, I encourage you to put a note here. See, this is capital, this is small. I don't know what happened. So actually W means work done. So we actually learn work done in Form 2. Work done means energy used. They are same thing, huh? Work done means energy. Okay. Yeah, it's energy lah. Work done is energy. But the word different. So many people feel blurred. Work is energy. Work done is energy used to do work. Okay, so actually if you can remember and memorize this formula and relate it to E equals to HF, W naught equals to HF naught, KE max equals to half mv squared max. Solve everything. Okay. Okay, so now we wait, then why the formula here like this is half mv squared? So it's half mv squared max. I copy here equals to HF minus W. So actually I prefer you all translate it back. Half mv squared is KE max, its energy, equals to photon energy minus work function. So if you rearrange it, you will find out it's KE max plus W naught equals to work function, and you switch again. E equals to work function plus KE max. Okay, so if you understand this original formula, then you can just rearrange it by using your linear equation only. Okay, so don't remember other formula. You remember original, then you substitute, you move it around. Okay, so now okay, the graph is, they would show the graphs like this, and this is what page 208, page 208. Solving problem involves Einstein equation for photoelectric effect. So in an experiment on photoelectric effect, the graph of maximum kinetic energy chart, maximum Kmax against frequency. Kmax against frequency. Be careful here. This tree is not only tree, but this tree is 3, sorry. 3 is 3. Kmax actually is 3 times 10 powers of negative 19 joules. This F is not 8, but is 8 times 10 powers of 14 hertz. Actually, what is hertz? Frequency equals to 1 over period. Frequency equals to 1 over seconds of frequency. What is hertz? Hertz actually is S powers of negative 1. So frequency is hertz. So actually hertz is per second. Okay, so be careful. When we read the graph, we need to read this. Not only 3, but 3 times 10 powers of negative 19. Not only 8, but 8 powers, 8 is 8 times 10 powers of 14, right? Now, emitted photoelectron from the metal surface is found to be a straight line. Yeah, it's a straight line. So now, calculate what is the threshold frequency of the metal. So you can see electron will only release. See, all 0, but only starts now. We have electron coming up with maximum kinetic energy. Means this A will be your threshold frequency. Okay? Yeah, how to calculate. E equals to HF. So KE means frequency. So this is the threshold. Okay. I got it. Okay, let's write the original formula. I don't like this. I prefer you all write E equals to W plus K max. So let's draw it. Let's write E equals to what function plus K E max. Okay, then here I will substitute its original formula. HF equals to HF naught plus maximum. This one no need half mv squared because they don't give m, they don't give b, but actually they already give maximum. So this one no need. Just substitute 3 times 10 powers of negative 19. Then for me, I will treat it like x, like 3x equals to 4x plus 3. What will you do? You move to one side, alright. So I will move to another side. I will say HF minus HF naught equals to 3 times 10 to the negative 19. Up to you, I believe your linear equation good enough. So lazy person, I would like to factorize out. Then this is a constant, then I sub in. So this one, when I move here, it will be F minus F naught equals to 3 times 10 powers of negative 19 divided by a Planck constant. So actually, F naught would be TF. Okay, F naught will be 3 times 10 powers of negative 19 over 9 minus F. So I will switch it again. It will become F minus 3 times 10 powers of 19 over H. Yeah, the F maximum F is here, 8. Okay, so 8 times 10 powers of 14 minus 3 times 10 powers of negative 19 divided by Planck constant 6.63 times 10 powers of 34. 6.63 times 10 powers of 34. Okay, press calculate. I think answer is 8 times 10 powers of 14. Right? Let me check one more time. From something. I press something. 3 powers of 减十九除以6.63 powers of 34. Okay. Something. Control circuit function. Resistance. Control circuit. Ah, 3. Huh? Why 3? This. Why 3? Oh, from the graph. Oh, just see from here. But the diagram is. But the diagram. But the diagram not balanced. The diagram not. Da. Diagram not balanced. Is it my illusion? Oh, seems like okay. Yeah, my illusion is 3. I'm sorry. My mistake. Bring you to the London. No, Holland. In Cantonese we say bring someone lost in somewhere. We say bring you to the Holland. 让你们去到荷兰了。Sorry. Actually, just no need calculate, just see from the graph. Okay, maybe I feel it's not at the center. Okay, actually it's at the center. So in exam, actually yeah lah, here lah, A is 3 lah. So no need so much. Yeah, no need. So answer should be just 3 lah. Threshold frequency is 3 times 10 powers of 14 s powers of -1. Means 3 times 10 powers of 14 hertz. Anyone per second, hertz also can. Okay. Then my fault. My fault. Sorry. Bring you all to Holland. Oh. Okay. Then work function of metal in electron volt. It's EV. So let's see. So maybe we do work function in joule first. If they give you joule, so we say work function equals HF newt. H 6.63 times 10 powers of -4 times 3 times 10 powers of 14 equals to 1.989 times 10 powers of -19 joules. But you need to change the EV. Just now we saw, actually what is 1 EV? Normally in exam they will give you the number. 1 EV equals to 1.6 times 10 powers of -19 joules. Feel familiar in chemistry? Check. I got it. Actually, it's same as the electrical charge. 1 EV equals to this joules. 1.6 times 10 powers of 19 joules. So we say 1 EV equals to 1.6 times 10 powers of 19 joules. So actually it's like your molarity. Okay, so the concept is like this. Like 1 dozen of pen is 12 pence. So if you have 18 pence, about how many dozen of pens. You got X dozen of pens. Can you tell me what is X? Yeah, 1.5. Or 3 over 2 or 1.5. So same thing lah. If 1 EV is this, so now you have 1.989 times 10 to the 19 joules. You got how many EV? Same thing lah. You cross and you divide lah. Okay. So W naught equals to this might divided by this, which is 1.989 power of negative 19 divided by 1.2414 EV. Answer 1.3. Right from the graph, since we got work function. Sorry. And what function is here? Not HF not right? Okay. I think I need to restudy this about graph. My fault. I'm sorry. I need to restudy this about so. Okay, so normally the photoelectric effect, where can we apply? That one I study first. Next week I redo. Now 211. We can use it in semiconductor to make it as a photo cell. Means solar cell. Photo cell means solar cell. So actually how light energy, how our solar cell, solar battery function actually is light energy shines on the surface and make electrons start to move around. Okay, the advantage is non-renewable, sorry, this is renewable energy and no pollution. Okay, so this 1212, you can check what is the function? I mean application. Is it here? What is this application? You can check. Okay, so okay, suddenly lost my confidence. That one got graph, this one no graph. Okay, so this is tugasan 3. Tugasan 3. Contoh 2. Tugasan 3. Oh, they give EV. EV. Okay, this E come from where? For this operator, you can press shift constant. You can press shift constant. Shift a constant is number 7. Then you will see this universal electromagnetic atomic nuclear. Press number 2. Electromagnetic. Press number 2. And you will see this. Number 3, E. Number 3, E. You press number 3, E. This E means the charge of an electron. Then you press number 3, you will get E. Then you press equal sign, you will get 1.6 times 10 powers of negative 19 coulomb of charge. Okay, so this one, I think next week we talk again. Then next week we solve this problem and the graph problem. I think I like study on the graph. I will study. Then we will start chapter 6, nuclear energy. Okay. So now please do the objective. Please do the objective. 214 also objective. Okay. Then now okay, so this one quite easy. What is the wavelength of photon with this of energy? E equals to wavelength hc over lambda. 3.75 equals to 6.63 times 10 powers of negative 34 times 3 times 10 powers of 8. If you forgot is in here. C under nuclear divided by lambda. So you bring it up, then you convert it back to nanometer, right? Okay, right, number 6. What is the answer? So actually this is KE max equals to E minus work function. This W is work function. So what is work function? Thank you. Back to me. Thank you, Natasha. The rest. Their minimum energy correct already. Maximum directly wrong. Maximum is kinetic energy. So is it minimum energy of free electron in the metal? No. This two seems like the same to ionize one atom. Okay, ionize means it would be, let's say, Cu, maybe Cu plus, Cu2 plus, Cu3 plus. So ionize means it could be release out one electron, two electron, or three electron. So ionize not suitable. So answer yes would be C. A photon can eject one, with just one photoelectron, right? So ionize would be plus 2 plus 3 plus. Could be 1 electron, 2 electron, 3 electron, but this one is just one photoelectron. Okay. Can you please tell what phenomenon can show electron have wave properties? From your textbook, actually. Okay. Can be diffraction, can be interference. This is diffraction pattern of electron, and this is diffraction pattern of red laser. So we say diffraction. Here is a trouble textbook. Okay, maybe we should bring back the textbook. I think I need to restudy this. Sorry, everyone. Sorry, I thought I knew already, but not yet mastered. I'm sorry. Okay, so next week we try to use less than 1 hour study this, and we study nuclear physics. Okay, sorry everyone. Thank you for today. At least you know photoelectric effect, light, metal, emit direct electron. Alright. Okay, thank you everyone. Bye-bye. Bye-bye. Thank you. Thank you. Bye-bye. Thank you. Bye-bye. Amali question, I don't know yet. I also don't know. Tuesday night, I asked Fernando Mama what is it. I can try like I do. Yeah, maybe next week we can make Amali test preparation. Usually what topics come out, I also don't. Can be any topic. Okay, bye-bye.